Hello students. In our previous video, we learnt about two hyperbolic functions, sin h inverse of x and cos h inverse of x. Now here we are going to learn about tan h inverse of x, and it is given by 1 by 2 logarithmic of 1 plus x divided by 1 negative x. So now we shall see the proof of this. So first we shall consider the left hand side. What is our left hand side given? It is tan h inverse of x. So this tan h inverse of x, we are going to make a substitution as y. As we saw in the previous problems, the same method we have to use here. So tan h inverse of x is equal to y, and from this we obtain x to be equal to tan hy. As per the formula of tan hy, we have already learned that tan hx is equal to e power x negative x divided by e power x plus e power negative x. Now we will substitute this. So at the place of x, we have to replace it by y because we have tan hy here. And so this will be equal to e power y negative e power negative y divided by e power y plus e power negative y. So now in this can be written as e power y negative. This e power negative y, when taken to the denominator, it becomes e power y divided by e power y plus, again this e power negative y, when taken to the denominator, it becomes e power y. Now we will take the LCM in the numerator, and so we get x to be equal to, what is the LCM over here? It is e power y. So the LCM is e power y, and so we have to multiply this e power y along with this e power y, and so we get e power y the whole squared negative 1. The whole divided by, here in the denominator also we can take the LCM to be e power y. And so here this gets multiplied with this, and we get e power y the whole squared plus 1. And now what happens is this e power y and e power y gets cancelled, and here we are left out with e power. Now this e power y the whole squared can be written as e power 2y, because 2 is the power of the whole term. So we can multiply these two. So when we multiply y with 2, we get 2y. So it will be e power 2y negative 1 divided by, now here also the same way, this can be written as e power 2y plus 1. So now actually what is this? This is x. So we can cross multiply this denominator with x, and it will become, so x gets multiplied with e power 2y plus 1 to be equal to e power 2y negative 1. Now we shall multiply this x with e power 2y. So it will become x e power 2y. Then this plus, and again x gets multiplied with this 1. So x multiplied with 1 is x is equal to e power 2y negative 1. Now we can bring this e power 2y to the left side, and so we will be getting x e power 2y. Then this, when comes to the left, it becomes negative e power 2y is equal to this x, when taken to the right, it becomes negative x, and here we have a negative 1 that we will write here. Now if you see here, the term common over here is e power 2y. So what we are going to do is we are going to take negative e power 2y common. So negative e power 2y will get multiplied with, here we have a positive sign. So we must, when we take negative common, this has to become negative x, and this negative has been taken out, so here you will be having a positive sign, and it will be 1. And on the right also you can take a negative sign out, so it will turn out to be x plus 1. So this negative gets cancelled, and from this e power 2y will be equal to, this can be written as 1 plus x divided by, and negative x plus 1 can be written as 1 negative x. So now we have obtained e power 2y to be this. After this we have to take logarithm on both the sides. So taking log on both the sides. What do we obtain? Log of e power 2y is equal to log of 1 plus x divided by 1 negative x. Now this 2y can be written in the front, and so it will be 2y log e is equal to log of 1 plus x divided by 1 negative x. Now this log e is equal to 1. So therefore what we obtain is 2y to be equal to log of 1 plus x divided by 1 negative x. So from this our y will be equal to 1 by 2. Taking this to the right, it goes to the denominator. So 1 by 2 log of 1 plus x divided by 1 negative x. But what is y? As per our substitution in our beginning of the problem, we have taken y to be tan h inverse of x. So we shall replace it here. So y will be tan h inverse of x, which is equal to 1 by 2 logarithm of 1 plus x divided by 1 negative x, which is the required proof. That is, we have proved that tan h inverse of x is equal to 1 upon 2 logarithm of 1 plus x upon 1 negative x. So we have proved the required result. Hope you have understood the proof of this. The derivation of all the three hyperbolic functions is very significant. They are even used as formulas in various problems, and so we have included that too in the formula list. This is the inverse hyperbolic functions, where sin h inverse of x is logarithm of x plus square root of x squared plus 1, cos h inverse of x is logarithm of x plus square root of x squared negative 1, and tan h inverse of x is equal to 1 upon 2 logarithm of 1 plus x upon 1 negative x. Thank you.